Thank you. I'm really excited to be back this year. And again, I promise you it's going to be a very, very interesting session. We have a lot of things to talk about. But the most important, today, at this stage, in this session, we're going to announce a strategic alliance and partnership. And we also launch a new product, which literally will change the way products are made. And that's a very, very exciting thing. So join me for the next 45 minutes and experience how digital manufacturing and additive manufacturing is going to revolutionize the industry, how it's going to change the entire product life cycle, from the begin, the idea, to the finished product. This technology is in transition. It's in transition from prototyping into manufacturing. And ladies and gentlemen, it's happening now. It's happening now, and it's happening here at this stage today. So, the future of additive manufacturing of 3D printing is in manufacturing. This is a trend which you cannot hold, and everybody needs to get up and understand what's going on here. This is the future. The future of 3D printing is in manufacturing. So, in order to unleash these new capabilities, and in order for you to develop more innovative products faster, you have to really understand what is behind this. You have to liberate yourself from traditional process, from traditional thinking. You have to liberate your engineering creativity in order to really, really utilize this technology. It is not so much limited today, the potential of this technology, by the technology available today and what we have seen, what is coming tomorrow, but by our ability and your ability to utilize this technology. Think in turning design for manufacturing, which is the traditional way of doing it, into manufacture what you design. Manufacture what you design. And that means think it, model it, and make it. So this is the slogan of this session: think it, model it, and make it. And you will see a lot of examples why this technology is really a game changer. Listen, I have visited a lot of customers, I have visited a lot of companies involved in this, and I learn every day this technology is amazing and it can do amazing things. You can actually design products which you couldn't make before. You're totally new designs which can change the performance of your products dramatically. And that is a technology which helps you with this. It also reduces production costs in certain series. And at the end, and we'll see a few examples, it speeds up time to market. You can really do things faster, much faster than with traditional technologies. You can eliminate your inventory, and you can produce wherever you want, at any space and time. If it's on the world or in space, they actually put a 3D printer on the space station already for spare parts, which is a funny thing. So, anyway, this is a game-changing technology which allows you to do things which are completely different to what you have seen before. If you look at the market growth, this market is growing like crazy, double-digit in the next years. And important to see here is also that there's a large service part to it. So if you're in the service business, I mean, that's your challenge. That's your potential here. And the reason why it's a potential is because the companies cannot even apply this technology as fast as it's coming. And they're looking for service people who have the know-how and the skill sets to help them in the deployment of this technology. If you look into the product itself, then often people tell me, yeah, this is only in the consumer market, all this hobbyists and printing toys, that's a big market. No, it's not. The growth in this market is in the industrial printing. That is where you are in, and that is where the growth is. And obviously with it goes the material market. The material market will explode It is the differentiator for you. You can make your materials in the future. There's enormous research going into this, and you can differentiate your product by making your own recipes in the materials. This will be a change in how you think. You are an engineer who can define your own products with your own materials and define differentiator for your products as you go. But the next slide is even more interesting. Why companies buy 3D printers? This is from Gardner just recently in March this year. And you can see that actually nearly 75% of this feedback is due to manufacturing reasons. They buy these printers because they want to develop new products. They want to make innovative products. They want to improve their products. And that is why they buy these printers and get into this technology. Again, the future of 3D printing is in manufacturing. It's nowhere else. It's not in prototyping. That is a technology we all understand. But the future is in manufacturing. So, all of you know by now there's a lot of technology out. I'm not going into a lot of details. There's obviously the two main areas, plastics and metals. And in metals we have metal deposition technology versus powder bed technology. Same in plastic. You have the traditional FDM and the real 3D printing, which we saw a couple of examples in the last weeks, which really will revolutionize on the printing process. So there's a lot of technology on top of this. I'm not going into the details. I just want to make sure that you understand the market is not one 3D printing. There's a number of technologies, and each of these technologies have a certain area where there are strengths and weaknesses. And again, the metal market is moving up, strongly moving up and taking over. In the industries, if you think that is not for your industry, you're dead wrong. Dead wrong. There's in every industry, there's examples for this technology. By the way, the revenue and the printing market per industry is really pretty much even. And it's not just complex parts, which maybe some people think. It is applying to every and each industry we know. And that's the important thing. So there's no one industry circled out. You can apply this to every industry. A few nice examples, and I like these always, and there's so many I could show. But just to give you an idea where this technology really is applied very successfully, and where it shows this is going into production is the aerospace and defense industry. You see here the temperature sensor, housing sensor. That's the first FAA-approved 3D printing part, which goes into a jet engine. And you also know from the very famous GE fuel nozzle, that's a part which is going into production next year. They have really taken a very, very complex part, which is 20 single parts, and put this into one printed part. And that's an enormous thing, and actually the part has 5 times the strength of the old one. So enormous transition of what you can do with these technologies. And by the way, Airbus just announced a couple of weeks ago that they have over 1,000 parts, printed parts, in their new A340 XWB. And that's enormous, and it's growing. Obviously, there's a lot of plastic parts, but this technology is taking really its way in the aerospace industry. But not only aerospace, you saw that in the industry map. Automotive is using it too, and you say, why can I do that with this large series? No, they're taking functional parts, particularly in the area of small first null series, and that's where the automotive industry is very interested to quickly go and produce these functional parts and prototypes parts for a first series. Another very interesting is mold and die. The mold area with the interesting equidistant cooling channels, a very, very difficult problem. 3D printing can help here, and also obviously complex parts. But there's also the possibility, which I saw last week, of plastic molding. And for prototypes, for small series up to 200 parts, you can use the printing process to print a complete mold, which obviously is available in a way of a day or two, versus making a whole mold, which is very, very expensive. Last not least, medical industry. The medical industry has really taken that on from a large amount of different parts, limbs, hips, and whatever you can imagine from, and they personalize this. And one very interesting example is here a customized prosthetic where people who develop that can really change life. No? This is a nice example of this young boy where two engineer students from a university in Midwest really developed this prosthetic and customized it and give this boy a new life. This is amazing, and it's an amazing story. Check it out on YouTube. It really, really touches you. So this technology helps everywhere. But what accelerates the adaptation? And you all say, wow, this is very expensive, and it's very expensive too, and it takes a long time to print. Exactly, those are the two factors the industry is working on. They're working on the reduction in cost, and these printers will get cheaper, definitely. This is from the Wohler Associate report. And the speed. The speed is enormous what's going on. And I guarantee these numbers are probably too low from what they already think about. So these are two main factors which happening in this market. If you look on the cost model, again, a little bit more detail, the implementation of casting is a big area for additive. Typically, the cost of a casting is very high if you only produce a slow number of parts. It goes, the cost of a part is then obviously declines if you have a large number of series, a lot size. No? With additive, it's the opposite. It's always the same price. It's always the same. And today it's relatively high. So only racing car manufacturers, they produce a whole cylinder block or an engine block, and very, very low lot sizes, this works. But in the next 2 to 5 years, the cost will go down, and this allows you to really do even lot sizes up to 1,000 parts, very cost effective in additive. What that means is you get more individualization, you can do smaller series for a certain market segment, you can build new business models, and that allows you this technology. On the other side, the cost for complexity, product complexity, is the opposite. As typically, traditionally, if the costs of complexity goes up, as high as the complexity are. In additive, it really doesn't matter. It stays the same. So you can really produce relatively complex parts. Obviously, there's a break even today. And this break even also will move down. It will come down, and it will be giving you the freedom to actually do more complex parts, more complex castings, which allows actually to reduce the weight. You can introduce lattice structures, and which allows better performance, more cooling, and this will be the capability to really introduce more complexity for less money and introduce more innovative products. So what's happening in the software industry? And I will get always asked, what's the trend? What's going on there? Today, we have a lot of specialized software. We have the hardware vendors who have their own software. We have a few independent vendors, very, very specialized in this segment. And the traditional PLM, CAD, CAM vendors, they try to support that with maybe an STL output, a very, very dumb format, which gets moved down, and there's a little bit in open source, but it's nothing like they are involved. What I think is going to happen in the future is the following. We're going to see on the one side, on the low-end side, a very automated process. STL will be removed by new standards, which company and consortiums working on. There's AMF, Additive Manufacturing File, and 3MF. And this will drive a very automated market. The other movement is really the integration and the demand of moving that technology into the PLM process. And that's something I want to talk about. This is more important because you as an engineer need this technology during your design phase, during your engineering phase, while you analyze your products and while you manufacture it. You have to understand that technology. And that is why this market will grow. While the specialized software is probably decreasing over time, and the companies or the vendors, hardware vendors, will work together with the traditional PLM vendors to drive this technology. So there's a huge movement over the next 2 to 3 years, 5 years, going on in that technology. So what are we doing in Siemens? What is our agenda? We have actually looked in that for the last 1.5 years very intensively. We started, as typically all start, in the manufacturing area, and we talk about that at the end. But we're also looking very intensively what that impact is for design. And there's a lot of things we currently are involved with, developing and prototypes, and you will see this technology more and more taking part of our traditional design system. So some of the things like design rules and conditions for additive is a very new field. We have a number of research projects on this topic. Design of lightweight structures, as you could see here, that's a major advantage of additive. It's also something we work on. Complex surface patterns, or the support structure idea, which is very, very important on how you position your part and how you build your part. And there's a whole thing in materials going on. Multi-materials, the way you can build parts out of two materials or created materials, is an enormous technology which has to be captured from the design phase onwards downstairs. The same thing in CAE. The engineering part is the most important part. Today, everything is really taken with a very dumb format over the wall to the manufacturing side. You need to have engineering tools to understand what is the structural analysis, what do you do in heat transfer, deformation, level-based analysis, and you have to regulate your path, regulate your power based on what you want to do and based on your part. So topology optimization, all these things have to be integrated, and there's a feedback loop to the design and to the optimization. Last but not least, in CAM, we are looking into not only one technology, we look over the entire spectrum, and we're working with a lot of these vendors to understand what that means from a manufacturing point of view, how do we implement that, how do we do this technology more integrated in the entire product life cycle. So the challenge today is really moving this technology. What we have today is really an uncontrolled environment. You have your design part, you export an STL, and that is where your managed environment normally ends up. And that's a typical problem in prototyping. You export something out of the managed environment and prototype around this. But this is not what a production environment can do. In production environment, you really cannot stay in an unmanaged environment where you have different type of technology to basically come to your printed part. There's a little statistic which I read a couple of weeks ago. They say 50% of the initial designs are unprintable. And this is because they're just pushed over the wall. No? And they all need, a lot of them need complete rework. They are typically using 2 to 3 different software technologies to position the part, to nest the part, to slice it, and so on and so forth. This is not our vision. Our vision in Siemens is to really have a fully managed PLM environment in NX and Teamcenter, which allows us to design a part, bring it in the analysis and optimization, define the laser path and the build position, generate the file which actually goes to the printer and prints the part. This allows us to really implement a feedback loop. This feedback loop gives you and the engineers the real feedback and the analysis that this part which you're creating is really working and it does what it's supposed to do. And obviously, we manage this in our data management, in our team center. We can take this down to the shop floor. We can treat the printer as a typical manufacturing environment, an equipment which is parallel to your traditional machine tools, and we can manage this from an end-to-end process. And obviously, as you know, with the Siemens environment we can link this into our MES structure. We can build an entire end-to-end process and manage this from a production environment. This is our vision. This is where we're going. So, at this stage, we're changing a little bit and talking about hybrid manufacturing. I'm really, really excited about that technology, and it's something which I believe is really changing the way products are made. I thought I explained a little bit how the normal printing process is. Here's the part which you can see is quite complex. It's supposed to be a jet engine housing type of thing. And this part, if you do it with a traditional manufacturing process, you basically have to go and take an STL file, as I just explained it, and you take it in a 3D printing software, and you basically print the part, and then you have a printed part. But the printed part is not ready. It's by far not ready to be used. So what you have to do, you start a second process. You basically take the solid model, you take the solid model in your CAM system, you generate an NC program, you generate another setup, and you put it on a CNC machine, the printed part, until you have your finished part. So what does that mean? This is one part, one design part, two export formats. You have two systems you work with to program. You have two machines, two equipment, and two processes and two setups. And you have to align all of this. So it's complicated. But it's not complicated if you use hybrid manufacturing. With hybrid manufacturing, you have one part, you have one system to program, you have one hybrid CNC program, and you have one machine, and you get your finished part. That's the revolution. That is the revolution. Additive and CNC in one system. Ladies and gentlemen, this is what it is. And at this stage, I think this is the moment we like to introduce and announce a partnership we have worked for over a year, and this is coming now, and we are introducing this as we stay here on the stage. So at this stage, I like to bring up Mr. Lell. He is the head of a Siemens Saar division of DMG. Maury, come on. I'd like to give Mr. Lell an applause. So the two of us together are here to launch this enormous and great technology. We're here to tell you that this solution is ready, the machine is ready, and the software solution is in beta testing, will be available to customers in the next 90 days. If you have still time, you can see the machine in Chicago, right?
Right.
Yeah.
At the moment.
And we actually wanted to bring the machine here to this event, but the hotel management was a little picky with the carpet, so they didn't allow us to bring it down, and then the doors were also not big enough to get it in. But what we have today is a very nice video, and with this video we want to show you what the capabilities of this machine tool is and what it can do for you. And with this I hand over.
Thank you.
Get the video? Oh yeah, okay.
Jetzt haben Sie das Licht besorgt. Yeah. And here it is. Good afternoon, ladies and gentlemen. I'm very glad to be here. Thank you very much, Siemens. Thank you, Andreas, Saar, for sharing the presentation with me. And I want to talk a little bit about the technology and about the way we came into this. First overview, I'm from the DMG Mori company. It's a corporation of the two biggest machine tool manufacturers worldwide, the DMG from Germany and Moriseki from Japan. And since 2 years, we have a common branding and we market the machines together worldwide. In total, we have a revenue of around about 3.2 billion euro with 11,000 employees worldwide. We are running 21 manufacturing places, mainly in Europe and Japan, but also since 2012 we have a pretty nice manufacturing factory in Davis, California, where we produce mainly for the American market. As a global company, of course, we need local presence, so we have 145 local subsidiaries which are in charge of sales, service, and training for their markets. I myself, I'm coming from the Saar company, which is part of the group and in charge of the advanced technologies. We are having on the one side the ultrasonic technology, which is doing ultrasonic grinding of very hard and brittle material. But this technology is also good for composite machining and for milling of super alloys like Inconel or titanium. On the other side, we have the laser factory, the laser tech, and here we have different laser technologies that all have in common that it's high-end applications which need 5-axis, very accurate 5-axis machine tools, which need a lot of software and a lot of laser technology and process know-how. And the latest of it is the additive manufacturing. That's what we talk about a little more today. So let's look at the laser itself. The laser is a pretty new tool. It has been invented in 1960, and it took a pretty long time until it went from the scientists into the industry, and they found a use for it. And in the 80s, it was introduced into manufacturing for sheet metal cutting, the laser, so not too long ago. In the meantime, the laser has become a commodity, as you all know. It's used in every CD player. You find a laser in the telecommunication, in the defense, healthcare. It's in our daily life. And if you look in the manufacturing, the laser has been a substitute for a lot of conventional processes like welding, 3D cutting, hardening, laser engraving, and even drilling. The laser often shows to be more efficient and giving a better quality at the end. Now, with the additive manufacturing, the laser comes to a new level because it's not a substitute, it's a complete new process of production, of producing parts. And so it's a new level and it brings us new opportunities also, like you've heard today already. So we thought with the additive manufacturing what we're going to do, because all the additive manufacturing methods that we evaluated in the metal field, because we are a metal machining company, all these technologies did not bring the quality and the accuracy that our customers are used from our CNC milling and turning machines. So it was the idea that we put the additive manufacturing, like a laser deposition welding process, directly into a machine tool so that we can combine the quality of the milling with the flexibility of the additive manufacturing. And this idea we presented to our board and in September 2013, so just over 1.5 years ago. And we get the approval, yes, we can develop it, but we have to have a prototype on the next exhibition, which was only 2 months later in Euromold in Frankfurt. So within 2 months, we built a prototype, or I would call it a functional study, but it was a machine that was able to build the part you have seen already today, and we had a tremendous result. We had a crowd of people around the machine the whole 5 days of the exhibition, and we were lucky we put a huge screen next to the machine so that the people who could not look into the machine at least could see the principle of our technology on the screen. And actually, someone made a copy of the video with a phone, and the next morning you could already watch it on YouTube. It has become one of the most watched technical videos on YouTube. So it was an easy decision that we continue and that we develop a serious machines, and that was introduced in the United States the first time last year in September at the IMTS exhibition, and 1 week later in Stuttgart in Germany, and in November in Tokyo. Again, you see it on the picture, every time it was a huge crowd around the machine, and we had always the biggest number of product interest for this machine compared to all other displayed machine tools. So what is it? What we do, we use a 5-axis universal milling machine with a trunnion table, and we integrate the laser head with an automatic exchange possibility. So we have a shuttle that moves the laser head in and out when we are, so we can change automatically from build up to milling, and build and mill. And so even areas that cannot be reached at the finished part, we can mill in between. And when the machine is milling, the laser is completely outside the working area. We can use high pressure coolant, the tool changer, and everything we need to get a good result from the milling side. So with this machine, we have in the meantime already different variations. We offer the machine also with a FD option. That means a turning table included, that we can turn and mill parts if we have rotary symmetrical parts. And by the end of this year, our Japanese partners will launch the technology based on a turning center with a milling head included, so for long parts. So it becomes a whole family, and of course, all these machines run on the Siemens Sinomeric 840D controls. Another surprise, not only the number of people who are interested and companies who are interested in our technology, another surprise was a big variety of applications. We mainly thought about building parts, of course, not only prototyping, but also production, small series, mid-series, and we certainly had inquiries for these applications, but we had also a big number of inquiries for repair in the mold and die industry, in the aerospace industry, turbines, gas turbines, and many other applications. And even for coating applications, we have big interest for doing coating and then partially finishing the whole part afterwards with our chip-making technology. Mold and die, bearings, rollers, and also a lot in the oil and gas industry. Here is some example. We recently did a small turbine blade about 3 inches high, built from Inconel 625. You see it here, milled down halfway. If we build it up and mill it down the full way, it takes about 50 minutes for one part. On the other side is a diffuser made from stainless steel, and this has about 14 inches in diameter and 2 inches high, and it takes about 110 minutes for building and about the same time for finishing with the milling. So some different application, and you see the flexibility. If we compare our technology with the traditional or the more established powder bed technology, the typical 3D printer, we see that the 3D printer, because it's only building in one direction, is a 2.5D technology, but is capable of doing very fine and intricate parts with a very slow build rate. Our technology has a much higher build rate, about 10 times faster, but therefore is more for larger parts and not the very fine detailed. And, like you know, we can directly finish. So, if we look at the whole process, it's much more than a machine. The first question, of course, for us was, how do we get from the CAD model to the finished part? And there was a very quick way to Siemens and to start the cooperation with Siemens to get a good software where we have the additive and the subtractive process in one programming system. We don't want our customer that they need different software solutions for the different processes. It will never be successful. Besides that, there's a lot of development from the materials. Every material needs laser parameters, needs process parameters. The process itself needs a closed loop control, needs measuring technology, needs simulation, and also here Siemens can be very helpful. So if you look at the whole picture, you see the whole process is much more than the machine, and it's a very challenging and interesting project, and we are happy. We have now about the first 10 machines we have sold. The first 5 are installed, and of course our targets for the future are much higher. Good. Thank you very much. Andreas, yep. You continue.
Thank you very much. Okay, I like to wrap it up. I think you have earned the evening event. We, as you saw, this is a total solution. It is not just a machine, it's not just software, it is an integrated part of what we're delivering to our customers to make this technology happen. It is an integrated system. We made a clear decision from Siemens' side that this is something which we want to really, really tightly integrate in our standard software and allow a fully associative model with visualization of both processes in one system. And it is a 5-axis system. That's why it's more complicated than a standard 2-axis things. And there's a lot of things you have to consider in this type of a process. And we have worked hard together, and that's why we're happy to be able to launch this today and make it available to the market. And I'm pretty sure you will be excited to see this too. And there's many more exhibitions where this will be available. But there's one session today, not today, on Thursday, at after lunch in Austin 3, Complex Machining, and we'll show you much more detail on the software solution, and you can see and ask questions about the details. To wrap it up, the industrialization of additive manufacturing is happening. It's in the process. Manufacturing is the future of it, and there's a lot of people who have started to look into this technology and successfully applied it. And I think this is going on. Nobody can stop that anymore, and you all should get involved and get excited and start back, think about this from the design, the initiation, the idea of it in a product down to the manufacturing process. We as Siemens will support you. We have a whole stack of technologies from the enterprise, what we have seen today, down to the shop floor. We saw we're using our control systems in that technology, and we're supporting you in deploying this process. Because at the end, you have to have an automated process where parts and material can be automated and flow into the production site. So, if you have any question and are interested to basically deploy this technology, we are your partner. We're working with you and we're supporting you in the deployment of this technology. I hope this was an exciting session for you. Again, the future of 3D printing is in manufacturing, and it's starting here and right now. And thank you very, very much for joining that session. And I wish you a nice evening and a nice rest of the event. Thank you very much.